Hello, my name is CyberSecurity. I'm here to explain my ICP1 for the AI in cybersecurity. Deep learning with Python. So for the first exercise, we have randomly assigned, initialize the weight and bias values. Use the sum function for summing the values and for multiplication as shown below. So we use this feed weights and the bias values by in the sum to get the multiplication output. So using the torch manual function, we have performed the matrix multiplication and torch.sum for the sum values. So this is the torch sum and using torch.sum for matrix multiplication and activation function to get the output in range of 0 to 1 or minus 1 to 1, and this output is stored in the hidden layers. So the hidden layers which we are provided is around 2, and the output layer is 1 and input layer is 1. So that's it in the part 1. Coming to the part 2. So let me run this thing first. So flatten the image using the function reshape, created random weight and bias for input of size 7, 84 and 256, and did manual of the input of and W1 and sum with the bias to get hidden layers and send the out to the sigma activation function, and did the same for the hidden layers and W2 to get the output layer. So softmax function ratio. Softmax function is the ratio of the exponential x to the total sum of all the exponential of x, that is torch exponential and the sum of beam is equals to 1 to reshape used to perform some operations on the column. So this is the torch side. Is with the output which we got. Linear is the function used to perform linear transformation and used rectified linear unit activation function, and for output layer we use softmax activation function. As you can see here, hidden layer with soft sigmoid and the output layer with a software calculation function. And the model weights and bias looks as follows. Use the log softmax function for output and used an NL loss function to calculate the loss. AutoGAD is used to perform backpropagation, and we use automatic gradient descent operation calculated to loss using NL for loss function, and backpropagation is done using the loss backward and use optim SGD function to reduce the loss by correcting the learned values in the backward. So we use linear, low, and linear sequential, which we got the probability of this for the line. Thank you.